It is raining cats and dogs out there.
They say cats land on their feet, so they should be fine. It's the dogs I'm a little worried about.
Relax, Bert. Raining cats and dogs simply means that it's raining really hard outside. It's a saying.
You humans are weird.
Dr. Jeff, are we safe in here?
Don't be such a scaredy cat. I was tying my shoe.
Right. To answer your question, Zoe, yes, we're perfectly safe. Engineers designed our lab to withstand all kinds of extreme weather.
Interesting. What kind of designs are we talking about?
I'm glad you asked. I'm Dr. Jeff Vineker, and today we're going to explore extreme weather solutions. Today, we'll learn that extreme weather is a result of natural processes. Humans can't stop extreme weather, but we can reduce its impact. And we'll see how engineers develop solutions to protect us from extreme weather.
With Dr. Jeff.
Welcome to Labracazam, where we make science make sense. So what do we mean when we talk about extreme weather?
Heavy wind?
Thunder and lightning?
Yes, and also floods, high winds, and heat waves. Extreme weather is any weather that falls outside the realm of normal patterns.
Like a tornado.
Or a hurricane?
Or bird poop. What? That stuff can get pretty extreme, let me tell you.
Extreme weather, not bird poop, causes a lot of damage.
Why don't we come up with ways to lessen the damage?
That's a great question. We can't actually stop extreme weather from happening, but we can reduce its impact.
Can we reduce the impact of extreme weather by trying to predict it?
Absolutely. By looking at past patterns of extreme weather, we know what regions on Earth are prone to different kinds of risks. For example, we know when it's hurricane season in the Atlantic Ocean by looking at patterns. Based on centuries worth of data, we know that the period between June 1st and November 30th of each year is when hurricanes are expected to develop across the Atlantic Ocean.
So each year, the people in the area near the coast can get prepared in case a hurricane happens?
That's right. How else can we reduce the impact of extreme weather?
What about coming up with new inventions and building methods to help lessen the damage?
Yes, we call those engineering solutions, and they help us reduce the effect of extreme weather. To take a closer look, let's break it down. This is a water wave machine.
So we can test the different ways of reducing flooding.
Exactly. Here's how it works. There's a paddle over here which moves up and down, and it makes waves that travel across the tank. Then over there, the water collects. It represents land, so we can test different solutions to flooding by comparing how much water is collected. First, let's see what happens with the tank in its current state. Here we go. What did we just observe?
The waves from the water spilled over, causing a flood.
Yes, they did. Let's measure the water to see how much spilled over.
Whoa, it's a little over 1,000 milliliters.
So that was a lot of flooding. Any solutions you could think of to prevent this from happening?
We could turn the wave machine off.
Yes. Anything else?
We could put up a barrier.
Perfect. We have a couple over there. Let's test them out. This barrier represents a high seawall. They're common on coastlines with really big waves. Let's see what happens this time.
Less water's going over, but it's still flooding.
Let's measure out the water so we can get a good comparison.
This one says 300 milliliters.
It's improved, but still a problem. What if we tried a different barrier?
I've seen these rocks along the coast.
That's right. They're similar to the big boulders we often see at beaches. Any predictions?
I think the rocks will stop the waves from flooding over.
I think the rocks will spread the waves, causing more flooding.
Let's find out.
They're blocking the waves.
That's right. Rocks like these slow down the speed of the water by spreading out the energy of those waves. Let's measure it and compare.
This says 100 milliliters.
So that's the best solution so far. Now let's try one more barrier. This is called a recurved wall, also commonly used on the coast.
Whoa, it's like a skateboard ramp, but for like, waves. I predict that the wall is gonna prevent the waves from going over.
It's pretty short, so it'll probably still float over.
Let's test it out.
It's blocking the waves, but it's also sending them back to where it came from.
Yes, the curved shape of the recurved wall prevents flooding by redirecting that water back out to sea. And it's the most effective way we've tested to reduce flooding on the coast. There are other solutions as well to reduce flooding. For example, constructing buildings in a special way to stand up to extreme weather.
When I visited Louisiana, I saw a whole town of houses on stilts. They built them high to keep rising water away.
There are also homes built on top of their garages. Better the car gets soaked than the whole house.
Our next type of extreme weather is high winds. We've built some model homes here to test out different types of roofs in extremely windy conditions. To simulate wind indoors, I'm going to use this extremely powerful air blower.
Look where you're blowing that thing.
My house has a gable roof, which has two sides that slope straight up to form an A shape.
Mine has a hip roof, which has all the sides sloping down.
I predict that the A-framed gable roof will work best.
And I predict that the hip roof will stay intact since it can deflect wind from all sides.
I'm going to use this ruler so that I blow the air exactly 1 foot away from each house, starting with Zoe's.
My house!
Sorry, Zoe. Gable roofs aren't the most effective against extreme wind. You can see that a gable roof has sides that are vertical or straight up and down. That means the wind can push directly against its surface like this, which allows it to provide a lot of force, and that pushes it off. Let's try the hip roof.
Man, that's one hip roof.
It is indeed. A hip roof, as you can see here, has all sides slanted up. This means that the wind doesn't push directly against the side. It gets deflected up, which means there's less force and it's likely to survive in extreme winds. Hip roof is the better roof.
Well, I guess there's only one thing to do now.
Now we're gonna look at lightning. This is a lightning rod, which protects against electrical surges from lightning. A strong roof is great for wind, but not a solution for lightning.
A lightning rod is made of metal and is used to transfer the energy of a lightning bolt to the ground through wires.
We can't prevent lightning, but we can redirect its energy into the ground to prevent damage to electronics.
Wasn't it Benjamin Franklin who was famous for using a lightning rod?
That's right. He wanted to capture electricity in order to better understand it.
Not only was Ben Franklin a founding father of the United States, he also discovered that lightning is electricity moving through the air. Let's test it out. This is an Odin coil, which creates electricity using similar principles as lightning.
Okay, let's strike the house without a lightning rod first.
Whoa, lights out!
An electrical surge can damage your home and appliances, but with a lightning rod,
The light stayed on.
The electricity flows from the lightning rod straight to the ground instead of through the buildings.
Labracazam, a simple solution to an extreme problem.
To see other solutions on extreme weather, let's go to some real-world science. In addition to floods, lightning, and high winds, there are other examples of extreme weather that affect us all the time, like this one. Tornadoes are columns of air that spin violently from a storm cloud to the Earth's surface. Tornado winds can reach up to 300 miles per hour. which is strong enough to destroy houses and uproot trees. While tornadoes occur all over the country, most occur in what's called Tornado Alley, a region in the US that stretches from Texas all the way to North Dakota. Because tornadoes are so unpredictable, engineers are coming up with new ways to reduce their destruction. For instance, they've developed special building panels that can withstand the winds of a tornado. These could be used to build a safe room in your home, so even if a tornado destroys the house, the room will stay intact. Woo! Another example of extreme weather, heat waves. A heat wave is an extended period of extremely hot weather. When combined with high humidity, it could be dangerous to humans. A heat wave with low humidity creates dry conditions that can lead to wildfires. Heat waves cause more loss of life per year than tornadoes, hurricanes, and floods combined. And though we can't prevent heat waves, there are many solutions to lessen their impact. Public health officials help provide access to cooling centers, public spaces with air conditioning. Energy efficiency experts create cooling solutions that don't depend on electricity, like painting over black roads with reflective white paint to lower temperatures. And city planners help plant trees along the streets to provide shade, which keeps people cool. Woo! That's better.
To battle the heat, I'm going to show you something really cool, how to make your own air conditioner. To make it, we'll need a styrofoam cooler, frozen water bottles, a plastic 90-degree tube like this one, a small household fan, a marker, a serrated steak knife, and tape and streamers are optional. First, place the plastic tube on the lid of the cooler. Then, trace around it as closely as possible for a snug fit. Put the fan face down on the cooler lid and trace it too. With the help of an adult, cut on the line of the plastic tube. For the fan, cut slightly inside the line so that the fan can rest on top of the cooler without falling in. Now load up your ice chest with all of your frozen water bottles. Now I'm going to put it all together, starting with my 90-degree angle tube. Now lay the fan face down over its hole. You can tape streamers if you want. Now it's time to turn it on. Air should be coming out through the tube. Air gets blown in and gets cooled by the ice. It then goes back out through the tube. It won't cool a whole room, but if you put it next to you, it'll feel pretty nice. There you have it, your very own air conditioner. Try it yourself.
Now, let's review.
Extreme weather is the result of natural processes.
We can't eliminate natural hazards, but we can reduce their impact.
Engineers develop solutions to protect us from extreme weather.
I finally came up with my own extreme weather solution.
Fur, I don't think that's going to protect against any extreme weather.
Oh, yeah? Bam! Solved!
Ew!
Where'd that even come from?
Join us next time on Labracazam. I'm Dr. Jeff.
I'm Izzy.
I'm Zoe.
I'm Bert.
Remember,
Always question, always wonder.